Good afternoon, everyone. Welcome to our first webinar of 2025. We are excited to share the latest innovation in MIDAS Civil and Civil NX, designed specifically for the ANZ region. My name is Young Park, and I am the account manager here at MIDAS IT Australia. I would like to express my thank you for everyone to joining us today. Before we dive in, and let me quickly walk you through our agenda for today's session. First, I will start with a welcome and provide an overview of the MIDAS feature updates from 2019 to 2024. Next, I'll hand it over to Pranav, a key member of our tech support team. He will walk us through the latest updates for 2025, including the next NX plugins and how they can be benefit for your projects. Finally, we will wrap up with Q&A session where you can ask any questions about what we covered. We will also share details about some exciting upcoming events. Let's start. We have a Q&A session at the end. If you have any question during the presentation, please leave us a question in advance. You can leave us question in the box shown. We will cover your query at the end of our presentation. If we can't cover all the questions, we will follow up with you through the email. And also, you can always contact us through our email anytime at our au.support@midasit.com. Let me share with our goal. It's to simulate the world with MIDAS technology. But what does to simulate really mean? It's about visualizing and experimenting with something before it becomes real. At MIDAS, this idea is our core of what we do. We focus on developing and providing advanced simulation software across a variety of sectors, including bridge, geotechnical, building, and mechanical engineering. Through this solution, we empower engineers and designers to create safer, more efficient, and innovation projects for the real world. Each of our solutions has its own unique feature, but for our bridge sector, we offer two main solutions, MIDAS Civil and MIDAS FEA-NX. Today, we will focus especially on MIDAS Civil. As a company founded on deep understanding of engineering, we take pride in saying that MIDAS Civil is purpose-built for bridge engineers. If you've already used our software before, you know it's easy to use and how user-friendly the interface is and help makes your work more efficient. Since 2000, our technology has been widely recognized. We were able to achieve over 90% of market coverage in South Korea. At the time, most local companies relied entirely on software from foreign companies, and the idea of homegrown solution seemed almost impossible. In this sense, MIDAS became a true pioneer in the architectural and structural engineering field in South Korea, leading the way for innovation and local expertise. Building on this success, we have continuously expanded our business into new sectors. Today, we proudly to have more than 1,000 employees, serve over 10,000 clients, and have distributed 90,000 licenses worldwide. Beyond the domestic market, MIDAS has grown globally, building a strong international presence. As of this year, we operate over 110 exporting countries and collaborating with 35 overseas distributor partners and have established 20 corporate offices worldwide. Now we're excited to announce that we launched our Australia office last year. And we are incredibly proud to share our growing list of key clients in Australia. This slide showcases some of the most respected engineering and consulting firms in the region who have trusted MIDAS solution for their projects. We have committed to continuing to support this organization, helping them achieving success in their projects. To ensure the best possible service and satisfaction for our clients, we've been hosting numerous training sessions, both online and offline. This session focused on key functions and workflows, helping our clients make the most out of the MIDAS software. Additionally, through dedicated Q&A session, we actively gather feedback from our clients and work hard to incorporate their valuable insight into the continuous improvement of our software. Since 2019, we've been introducing MIDAS Civil to engineering across Australia. To better serve the needs of region, we have continuously updated our software to align with Australian standards. Let me briefly highlight some key enhancements. In 2019, we introduced features like a basic material database, load combination, and a template function, enabling pre-stressed concrete design in compliance with AS 5100. In 2020, we introduced major improvements, including updates to the response spectrum analysis and the integration of the widely used Super T section database, a favorite among Australian engineers. Additionally, we launched an automatic calculation feature for various moving loads, such as rail traffic loads, to further streamline the design process. From 2021 to 2023, we've introduced several key updates, including code enhancements for pre-tension beam design and the auto generation of temperature loads for beam section. We implemented a feature to define time-dependent materials properties based on the method proposed by Gilbert and Ranzi, further expanding the software capability. In 2024, we introduced steel composite design based on AS/NZS 5100.6-2017. When combined with the steel composite bridge wizard, this provides a comprehensive solution for modeling, analysis, and design. With this feature, users can review design efficiently by inputting design variables, including stiffeners and shear connector information. The results are available in detailed reports, tables, and graphical formats for better understanding. Additionally, we have added TMR Queensland Standard PSC section to the software database, ensuring local compliance and easy to use. To further support engineers, we have also released MIDAS design guides based on Australia design codes for PSC and steel composite structures, providing practical references for efficient design workflow. Before I wrap up my session, I'd like to showcase some of bridge design we have successfully simulated in the past. Between 2019 and 2024, we have released 11 major updates incorporating total of 226 key improvements to refine our software's capability. As a FEM analysis software company, what I can promise on behalf of our team is our commitment to product quality and dedicated service. We are continuously striving to provide the best solution for engineers like you. We look forward to continuing this journey together, and we are confident that our shared efforts will lead to given greater success in the future. Now I'll hand things over to Pranav.
Yep, thank you, Yang. I'll start sharing my screen. Yes, I think. Okay, it will take 2 minutes. Yeah, I think it's visible. All right. So, hello everyone. My name is Pranav and I'm working as a structural engineer at MIDAS IT Australia. I will take you through the enhancements which we were working on during 2024 so that we will be equipped for an impactful 2025. So on the screen, we can see the updates for 2025 version. So these are the codal updates. We'll go through all of these in detail in the upcoming slides. I think there's a bit of lag. Yeah, all right. So this slide gives a glimpse of all the general enhancements or non-codal updates, I can say, that are incorporated in 2025 version. So henceforth, we'll understand the importance of each of these updates in detail. Yep. So AS 1500 released a new amendment towards the end of first half of 2024. It was amendment second, and that amendment consists some major updates in the formulations of creep and shrinkage. So we have worked on those updates and we have implemented the updated amendment, which is amendment 2, as you can see on the screen, and incorporated within the software for the 2025 version. We understand that the current projects will still use the existing formulations. So we have kept the existing definitions as the same, and we have added this as a new addition into the software. For general structures or building structures, we were a bit behind. We still had the 2009 version, but we have also upgraded the AS 3600 code up to the latest amendments, and also the compressive time dependent properties for AS 3600 is updated. Even the New Zealand standard, so initially the New Zealand standard was bridge manual 3.1. We have also updated the New Zealand time dependent properties as per 3.4 version of the bridge manual. All right. So this is regarding the B-double vehicle. So in addition to the existing standard vehicles that are already implemented, we also added a B-double vehicle to the database. Incorporating the B-double vehicle was possible previously as well via the user-defined option, which worked very well. But this addition as a standard addition will increase the efficiency and speed of the modeling for the users so that they can spend more time on later tedious rating checks. And yeah, we can see B-double vehicles for Victoria and Queensland with various axle spacings and different loading combinations are incorporated within the software. Okay, yeah, we were at the now regarding the general enhancements. So we'll start with the CQC3 directional load combinations. I mean, in response spectrum or seismic analysis, we are aware about 130-30 rule or SRSS method while considering the effects of major and minor axis in each direction. So while these methods work pretty well in terms of symmetric bridge, they have certain limitations when it comes to unsymmetrical or curved bridge structures. So to accurately capture the effects of each seismic direction and their dependency on each other, Caltrans has provided some guidelines in the form of CQC3 directional load combinations, and those guidelines are implemented within the software. Oh, I think the video is too far ahead. Yeah. And regarding the element stiffness, so in the previous until 2004 version, we also had an option to provide the element stiffness, but that option was applicable to the sections. So in case we want to apply different element stiffness, but for the same sections, we need to create a copy of those sections and then apply element stiffness through the properties dialog box. But with this element, we need not go through the usual definitions. We can just select few elements and apply element stiffness directly. We need not make a copy of the section stiffness for the sections. The last one is regarding the moving load tracer for elastic links. So I think this enhancement is pretty straightforward. As we can understand from the name, it allows us to locate the vehicle placement for the forces within elastic links. Previously, we used to go with workarounds, like in order to understand the actual forces in the elastic link, we used to check the shear force in the adjacent node of the elastic link. But yes, again, this is pretty handy when understanding the maximum placement or the placement of vehicle for maximum effects within elastic links or the bearings. Okay, yeah. Now, the last one, and certainly one of the most significant updates or the development which we have been working on for quite some time. So we are excited to present the advanced capabilities of general section designer. So traditionally, GSD was a tool that helps us with the calculation of section properties, interaction curves, movement curvature, stress distribution, etc. with reinforcement definitions. But in the latest update, the GSD tool has enhanced to include pre-stressing as a factor for its sectional analysis. So as we can see in the video, we can apply pre-stressing in the section, pre-stressing force, bonded, debonding types, and we can calculate the analysis. So this means along with your regular reinforcement details, the impact of pre-stressing force in the sectional properties can also be observed holistically. Yeah, you can see a onion curve and stress contours in the model in the video. All right. So all these developments which we just went through are just with respect to the ANZ standards. There are many more developments that have been incorporated pertaining to other global codes such as ASTO, Eurocode, Indian codes, etc. So, but since this webinar is catered just for Oceania region, we will just highlighting the Oceania updates. To view a complete list of all the enhancements, you can take a look at the release note on the MIDAS website. Okay. So now let's move on to the next bit. So this is something which I'm very excited about. It's automation. So although Civil is fully equipped with API capabilities, whenever we are on a business trip, we have noticed that there is a gap within the industry to actually understand the applicability or how to apply this API capability in their workflow. So we have also met many clients who want to go ahead with a complete automation in the first instance, but whenever they start to code it at a certain point, they lose interest and find it very difficult. So we understand that complete automation is the ultimate goal, but I think API is quite new to civil engineering. It is present for a very long time in terms of computer and IT sector, but I think it is still fresh in terms of civil engineering. So I recommend we start with very small plugins or automations which will quickly ease our tasks. So to address this situation and to give engineers and confidence, also an inspiration of how and in what parameters or what plugins should be created, we have created a few API plugins to address some of the frequently faced tedious tasks, manual tasks, so that we can make them easy and simple. So these are the three plugins which I'll be presenting: PY curves automated, iterative response spectrum, and debonding made easy. So let's look at these. So first one, PY curves automated. So again, engineers can relate to this. It takes a lot of time to create force deformation functions within the software. Usually we receive this data in an Excel format from geotech or a soil department in the company. And then we manually copy and paste each graph within the software one by one. And also we need to assign a particular property at respective depth of the pile. So again, that is another task. So to make this process quick, easy, simple, automation, so that from Excel software can pick up the graphs and also apply at the respective pile locations is created. So let's look at the video. All right, so on the left hand side we have Civil NX, and on the right hand side we have the Excel format. First, again, usual step, copy the MAPI key, establish a connection, and we have some material properties. So in this plugin, we are also giving a command to create the piles, because it was a bit tricky to assign the force deformation functions directly. So we are assigning the force deformation functions also creating the piles as we execute the plugin. Okay, so we have just clicked on py curves and we can see the py force deformation functions are created, and this is usual format for the py curves. So we can see all this depth corresponding to depth, whichever parameter is provided or the value is provided, py curves for that parameter are created. Okay, so now we select a reference node. This will be a reference node for the py curves depth. Then we'll select the top nodes of pile where we want the curves or the springs to be applied. In this data, in yellow boxes, we provide the respective definitions, material ID, and also the pile section ID. And yep, so material ID 1 is M40 and 5 section ID is pile. Again, some guidelines, how the plugin works, what are its limitations, rules to use it are provided in the same sheet. Then we click on create piles. So once we click on create piles, we will see how the piles are created one by one. So I suppose there are 6 and 6, 12 piles in this model, and yeah, these are created one by one. Obviously, their execution is being done one after the another. And yeah, I think in some time all the piles will be created. So not only the piles are being created, but also the force deformation functions are being generated. I'll just quickly go. Yeah, it gives an option like a pop-up piles created. So until whatever depth we have defined the force deformation functions, until that length the piles will be created. We can display the multilinear springs, and we can see multilinear springs at respective depths. So let's consider this. So this will be 10 node, so it should be usually depth 0 definition multilinear spring should be assigned at this place, and we can see so 0. So this definitions under 0 depth are applied to this particular point node. All right, so second one is the iterative response spectrum. So this plugin, I think, will be a major asset in the regions of high seismic activity like New Zealand, Papua New Guinea, Canada, Vancouver, especially in Canada. So this plugin performs linear analysis, so response spectrum analysis, considering the soil nonlinearity. So let's say we have defined soil nonlinear force deformation functions at the same functions which we have seen in the previous plugin, and also assigned it to respective pile locations. Now, response spectrum analysis, which is a linear analysis, considers the initial tangent or the initial stiffness of the curve of this nonlinear spring and conducts the analysis. Okay, the slides are changing, I guess. All right, okay. But in this, in these regions, the high seismic regions, we need to perform iterations by checking the displacement tolerance against the each stiffness provided. So we can observe from the diagrams provided in the screen, we can observe in the first image, if the displacement is beyond the tolerance limit, a secant is drawn and a new stiffness value is obtained. Now we need to redo the entire process again by considering the new stiffness. And as you can tell, this is a very time consuming task, and also this is being done manually, and it is also prone to very manual errors. So this entire process can be automated with API, and this is exactly what the iterative response spectrum plugin does. So we'll keep on calculating the secant stiffness. We can see from the image at the bottom, it will keep on calculating the secant stiffness and update in the model and reiterate it until the conversion tolerance is achieved. So now let us have a look at how it is done. Okay, so again, usual process, first connected to the server, and we look at the multilinear springs. Again, a sample, this is just a sample model, not a complete bridge. So it is required to create a structure group and a boundary group, an empty structure group and boundary group, because we'll use the boundary change assignment and just assign the particular group in the boundary change assignment for response spectrum. So two scripts, one is the main script and second script is the GUI script created using Python. Okay, this is the GUI. We select empty structure group, empty boundary group. We select either Rx or Ry, which direction we need to conduct the response spectrum. And in the left hand side in civil annex, we'll notice the springs values. So again, initial stiffness, initially x and y is the same. We applied the same nonlinear function in both of these directions. So we can see second iteration, since we have selected ry's stiffness is being updated, and in each iteration it will keep on updating. So yeah, I think it will change 2 more times. I think it runs until 7 to 8 iterations. Yeah, it says analysis is complete. We can see all the stiffnesses in each iteration and how they are updated in this same GUI, which is created using Python. And now we can perform the similar task for x-axis, and then we have a final deformation value. Okay. Now, yeah, it for a second. Okay. Now the last plugin, which is debonding made easy. So in Australia and New Zealand, there are a lot of standard pre-stressing sections, and often engineers provide various debonding lengths to the strands to satisfy the stress limit. While MIDAS is capable to provide a debonding length to these pre-tension strands, we have had a couple of feedbacks that the process is a bit tedious because each strand is defined with a single definition. You have to go to properties, and for each strand we have to update it. So for example, in case of a super T section, we have 48 strands in a single girder. So if we just multiply it by the number of girders in the single carriageway, or even in multiple spans, it would be a very time consuming task. So again, API comes in. API will be of help in such situations. So we decided to take advantage of API and create an interactive GUI within Excel. So that is not only easy, but also it will be convenient when providing debonding tables to the final contractor drawings. So this is how, with the help of VBA, we were able to map the tendon locations in such a way that it aligns with the actual position of tendons in the section. The same table in the Excel sheet can be copied and it can be pasted in a DWG file, then I think which will be forwarded to the contractor for actual pre-stressing on site. Okay, so now let's look at this video and how does this work. So this convenience is what we have addressed in this in creating this plugin. So again, standard Queensland section and a super T section is model. Usually at transfer check, we modify the debonding lengths. So just a simple support is being modeled over here. We can see again, these strands are auto-generated since database sections can use the auto-generation feature of tendons within MIDAS. So again, we'll connect it to the server, and this is the Excel sheet. Again, you paste the mapping key over here. So here we provide, this is just a reference image of how the naming can be provided, how the names or the grids are formed. And we'll check for element 15 in Super T and 39 in Queensland type of sections. So just enter the element. So it will select the sectional profile for that element. We click on get tendon data, and in this Excel sheet, we obtain a grid-wise layout of the tendons. We can also cross-reference it with the software section view. So in the properties, stiffness, we'll just select the same section, element 15, and turn on the tendons, and we can observe the same layout, two at the extreme top and left and right, and then some tendons in the bottom. So these are mapped at the same locations. Now to update the debonding lengths, again there are various rules, number of strands to be stressed in a single line adjacent to it. So we can just follow those rules which an engineer is familiar with. Enter the debonding lengths over here, 3000, whichever. So units provided over here should always be in mm. This is just a note of how the scripting is conducted. Click on update debonding length, and we can see within hardly 2 to 3 seconds the debonding lengths for the entire member is updated. For example, if you look at it, it is 13, so or 17 as well. 17 we have provided 3000, so 3000 mm. Automatically the debonding lengths are updated. And take a look at another, so 3, and if you look at it for 3 we have provided 5000 over here. Similarly, again few rules, as I mentioned, start and end debonding lengths will be similar. It is valid for straight tendons, because for draped tendons, again, debonding is provided, depends on various parameters. Some more modification in the script is required, but I think majorly straight tendons are used, so this is applicable for straight tendons. And this box also gives us number of tendons in a particular section. So now just checking for Queensland section, element 39, we have seen number of tendons is updated to 22. A different arrangement is seen, and again we'll just cross reference it with the tendon arrangement in the section view within the software. Same, we can just give some debonding length value, update it, and this can be conducted multiple number of times. Even if you have manually entered some debonding lengths within the software and then you click on get tendon data, the debonding lengths will be also extracted from the software in the same grid format. Yep, I think, yeah. And this hashtag shows the length of the debonding. So if it is in dash format, it says that it is a debonded tendon or strand. Yeah, all right. Yes. So just the last thing which I would like to address is, so all the plugins which were presented, to all 3 plugins were not created by any coding expert or a hardcore developer within MIDAS. It was created by a structural engineers who also act as technical support engineers, who you guys raise queries and we respond to. So it was created by structural engineers who use free source platforms such as Postman, various YouTube videos, ChatGPTs, and other to learn codes, to understand various functions of the codes, be it VBA or use Spider or use VB for Python, even for Grasshopper. So free source materials are more than enough to generate these kinds of plugins. And also ChatGPT is a lot of help in rectifying some errors. So yeah, that's all what we have used in creating these plugins. So I encourage everyone to take first step towards automation, and yes, connect more, create more. And as always, if you need any help from MIDAS in such automations or with respect to any software, please connect to us and we'll be happy to help. So thank you. And Young, over to you.
Thank you so much, Pranav. I'll share my screen again real quick. Can everybody see my screen? Okay, now before we wrap up, I would like to share some important downloads and upcoming events with you. On the left side of the slide, you will see the QR code. By scanning this, you can download plugins and they access the 2025 release notes for MIDAS software. On the right side, we have 2 key events coming up. The first one is we have the follow-up online training session. This session will focus on PSC composite bridge modeling, analysis, and design, specifically using QLD standard sections. We will also cover debonding, PY curve, and the relevant plugins to enhance the workflow. This training session will take place on February 27th and 28th, and the focus product will be Civil NX. We'll be sending out the invitation email for this event next week, so please stay tuned and then join us in the session. Second event that we have is the EA webinar focused on dam and hydropower design, scheduled for April 2nd. This webinar will dive into the application of FEANX for dam and hydropower projects. This is a great opportunity to explore how FEANX can streamline structural and geotechnical analysis for large-scale projects. We are also excited to announce that the expert will be our keynote speaker, sharing insight and his expertise on DEM engineering. If you're interested, mark your calendars and feel free to reach out if you have any questions. And don't forget to scan the QR code to access the latest downloads. And now we are moving on to our Q&A session. And if you have any question, you can, as I showed it earlier, you can type the question and yeah. And I have one question from Nathan. He has no audio. I'll send the recorded link to him in a separate email. And we have another question. The question is, if we want to modify the plugin script according to our own use case, can we do it? I mean, is the VBA script locked or is it free to edit? Pranav, can you answer this question for us?
Yes. So just that, of course, it is free to edit because it is scripted in VBA, which is an open source tool, and it is we even encourage to edit the scripts according to your own use case, because the plugin which were created were to address a particular issue. But if you want to just modify something to make it useful for your own project, then please, we encourage you to please edit the scripts, and if you face any difficulty, please contact us. We'll be happy to help. Thank you.
All right. Do you guys have any more questions? You're welcome. Oh, so we have one more questions. Is Civil and Civil NX 2025 release? Where can we check? This is a frequent asked question, so I'll answer it all together. So Civil 2025 is already released on 13th of January. Civil NX will be released soon, end of this week, or by next week. So you can look it up on our software on MIDAS website under product downloads. And do you guys have any more questions?
I think James has raised one hand. Okay, yeah.
All right. Just
Some
typing a
question
question now. For James, for debonding API, previously was advised to have node elements end at the different debonding lengths. Does the API automatically update the nodes, change the element length? Pranav, could you take this?
Debonding API, let me just read it again. Previously was advised to have a node element at the end of the different debonding lengths. Does API automatically update the node, change the element length? No. So whenever we provide a debonding length, it does not has to modify the elements, because we are not actually changing the length of the tendon, but we are just adding a debonding length and up till a certain point. So the elements are nowhere involved in this, just the debonding length can be changed.
I hope this answers your question. And next question, can the same license key be used for both MIDAS Civil 2025 and Civil NX? We are actually providing, we call NX maintenance. So it's the upgraded version of Civil NX, the standard maintenance. So yeah, I'll contact you separately, Brian, for the detail option for how to use MIDAS Civil NX. Thank you. And do you guys have more questions? Okay. James's question is up. So, hi, I've been using NX plugins within Grasshopper. I've found a bug that omits certain loads cases when applying beam loads. Is there any way to report this bug? Enough? Can you answer this?
Yes. So yes, James. So you can just raise a ticket in the support website, because in that manner we can include the developer and have this bug resolved as soon as possible. So I think you must be aware about, you can just go to support.midasuser.com and just raise a ticket over there. We'll check it out and try to resolve this issue as soon as possible. Since Grasshopper plugin is developed in-house, so we'll also address this plugin so we can readily address this plugin, the bug issue.
All right, thank you so much. And I hope if there is any more questions, we will wrap it up. So after this webinar, we will be, oh, there's one more question. Would I need to wait for the next update to fix this bug?
So actually it depends upon the complexity. If it is a small change with which the bug can be fixed, then a patch would be provided. Or else if it is something big which needs to be addressed, then yes, it would be implemented in the next update. But I don't think so it would be that big of a bug or that critical. So I think it should be resolved. Maybe you can once you raise a ticket, you can just send us an email with the ticket number at au.support.midasIT.com, and maybe we can have a discussion or try to expedite that issue from our end as well. Welcome.
Thank you so much. All right, since we don't have any more questions, I'll wrap this up. After this webinar, we'll be sending out the survey form about today's contents. Your feedback is very valuable and will help us improve future webinars and bring you even more relevant topics. We'd really appreciate it if you could take your time and moment to fill this out and send back to us. I really appreciate it. Once again, thank you and for joining us today, and we look forward to seeing you at our next event. I hope everybody has a great day. Thank you so much. Thank you, Pranav, for a great presentation.
Thanks, Yang. Bye, everyone. Yeah.
Bye.